Now, so whenever there is a question where we are having the sum of results as 9, 10, whenever I am asking you to find out the probability of getting a particular sum for 2 dice, simply we can remember, instead of finding all the possible cases, now let's see how we can remember. We know that whenever we throw 2 dice, the minimum sum we can expect is 1 here, so that the sum is 2, the minimum, and the maximum is 6 here and 6 here. So altogether it is 12. So the sum is minimum 2 and the maximum 12. Whatever the sum we are getting, that will be in between 2 to 12. Now, so simply you can remember by this logic, this is and this is exactly 6. So from this what we can understand is, if you throw 2 dice, the chances for getting the sum as 2 is only 1, and that chance is exactly 1 comma 1. So when you get 1 on both the dice, then only we will get sum as 2. And for 12 also number of chances is exactly 1, 6 comma 6. There is no other chance where you will get. That means these values represents number of chances, and these values represents sum of result. So in this way, these are the sum results. Suppose if you take that case where I want the result sum as 9. Now let's see, for 9 we are having 4 chances, even though you are finding you got the same. So in this way we can calculate the number of ways to get sum as 9 or 11 or 4 or 5, whatever the sum. So here easily you can take directly. Next, okay, suppose if the condition was, whenever we throw 2 dice, the first result should be greater than second. So we want a particular case where we are getting the result on the first die should be greater than second. So how it's possible? Suppose if I take 1 on this, it is not greater than any of the chances from 1 to 6, so I cannot consider 1 here. If I consider 2 here, it will be 1, so it is satisfying. Next I may expect 3. For 3 there are 2 chances, so 1 and 2. Suppose if I take 4 here, we are having 1, 2 and 3 on the second die. Suppose if I take 5 here, we may expect 1, we may expect 2, we may expect 3, we may expect 4. So any of these. Suppose if I take 6, it may be here simply 1, 2, 3, 4 and 5. That means here you may get 4, 1 or 4, 2, 4, 3, 3 chances. So let us count the total number of chances. So here finally only 1 chance, that's why here only 1, here 2 and here 3 and here 4 and here 5. When you count, so 6, 10, 15. So there are 15 chances. And coming to the probability, if I ask the probability of this case, simply the number of favorable chances 15 by total number of chances 6 square. So totally we are getting 6 square, that is 36. So answer will be 15 by 36, or if you cancel 3, 5 by 12. So in this way we can find out the number of chances what we are having. Next, so we discuss about the coins or dice. Suppose if it is related to chords. Now let us see chord. In order to solve the questions from chords, first you should know the structure of chords. Whenever I am saying a pack of chords, you should know the structure. So whenever you look at the chord pack, definitely you can expect 52 chords. So what we consider? So these 52 chords will be having in two colors. Generally we can find two colors in this, that is here black and red. We know that each color is having 26, so red, black. Next, so each color 26 chords again divided into two different groups. If I consider red, so these 26 red color chords divided into two different types, and again here black chords divided into two different types. So what are those two types? Let's see. If I take red color, so each one again 13 13 because two groups, so here also 13 13. Now let's see what are those 13 group. Now if you consider red 13, you will be finding 13 chords with this symbol which are called as diamonds. So these 13 chords with this symbol, diamond symbol, is called as the diamonds, and you can find another 13 with heart symbol, so these are called as hearts. Now in black color we can find some chords with this color, with this symbol, which is called as clubs, and in black the other 13 are having exactly a leaf symbol, so which are called as spades. So this structure is very important in order to understand the given questions and to solve them. Now there are four types. Now consider any type which is having exactly 13 chords, and again those 13 chords are divided into two different groups. Suppose if I take here diamonds, again divided into two groups, it is having 9, it is having 4. So these 9 are called as number chords, and these 4 are called as phase chords. So 4 are phase chords, 9 are number chords in each 13 group. So what do you mean by number chords? Generally whenever you look at number chords, we cannot find the number 1 chord or 0. Generally the number starts from 2 and continues up to 10. So 2, 3, 4 and so on 10, these are the number chords. And phase chords, what do you mean by phase chord? So you can find A, J, Q, K. These are the phase chords, and the names are, this is called as ace chord, and it is called as jacks, and it is called as queen, and it is a king. So the names if we consider, so totally 4. Not only in diamonds 13, in any other groups like hearts, clubs or spades, wherever you consider, so you can find the same, like 9 number chords, 4 phase chords. Now if you consider this structure, here in diamonds I am having a ace chord. Again if you find hearts, there will be another ace, and in black we are having 2 types. So in club again you can find one more, and even in the spades. So totally there are 4 ace chords. Not only ace, you can take king chord. So here 1, 2, 3, 4. So each and every chord will be repeated 4 times in each and every type, because we are having 4 different types. So every chord, not only ace, jack or king, even you consider, suppose I am having number 5. Number 5 will be repeated 4 times in each and every type. So like that you can understand the structure. So here the things what you need to understand, the points, important points are totally 52 chords, 26 red color, 26 black. Out of 26 we are having 2 different types, one is diamonds, other one is heart, and in black we are having 2 types, one is clubs, other one is diamonds. So in each type again we are having 2 groups, one is number chords and the other one is here phase chords, so that we can expect each and every chord which is repeated for 4 times. So in this way we can understand. Now let's see what are the questions we can expect related to cards. Now suppose if I take a card, when I am taking a card from this pack, what is the probability of getting a diamond card? The question is, when I am taking a card, when I draw a card from a pack of cards, what is the probability of getting a diamond card? Now, actually we discussed about coins and dice where the denominator was 2 power n in coins and 6 power n in dice. Coming to this, the denominator is always total 52 and we are taking some n number of cards, so denominator is always equals to 52 Cn. So it represents the total number of chances to select the required cards, so that 52 Cn. Now if you consider this case, what I am selecting, I want a diamond card. Totally how many diamond cards are available? 13. Out of 13 I am selecting one. Selecting one from 13 is nothing but 13C1. So this represents the probability of selecting a diamond card. So 13 by 52 or 1 by 4. So the probability of selecting a diamond card from the pack is 1 by 4. Now let us take the next question. Suppose if the question is, what is the probability of selecting a king card from a pack? Now we know that denominator is always 52C. We are selecting a king, means only one card we are selecting, that's why it is 52C1. Now what I am selecting a king card. So totally we are having 4 types and each type we are having a king. So all together we are having 4. Out of 4 we are selecting one. So this represents as 4C1. So the number of chances, the number of ways to select a king is 4C1. Total 52C1. As we discussed, number of favorable chances by total number of chances. So this understand the probability as 4 by 52, which means 1 by 13 is the probability. Suppose if I ask you to select 2 face cards, what is the probability of selecting 2 face cards? Totally 16 face cards are there. Out of 16 I want 2 face cards, so that 16C2 by total number of chances or number of ways to select 2 cards is, out of 52 selecting 2, 52C2. So in this way we can select here required 2 face cards in 16C2 ways, but the probability of selecting that is 16C2 by 52C2. Now the next one, which is some interesting one, that is, suppose if I ask you to select a diamond card or a king card. So now we want to select a diamond or a king card. For that, the probability we should consider. So the probability of selecting a diamond or king. First let us take the number of chances. For selecting a diamond card we are having 13C1 or plus for king 4C1. But here the point what you need to understand is, when I am taking 13 diamond cards, here when I am taking 13 diamond cards, indirectly you are getting a king card, and when you are taking 4 king cards, indirectly you are getting 1 king card. So here for diamonds and kings, so there is a card which is common, that is diamond king card. Diamond king card is common, so 1 card is common, that's why we should take -1. So this is the number of ways what we are having to select a diamond or a king, by So selecting one card only, you might be thinking here like we are selecting two cards, one diamond and the other one is king, but actually we are not selecting two. So what we are selecting, a diamond or a king. It may be either a diamond card or a king card, but not both at the same time. That represents only one. So that's why here you should consider 52C1. So that is how we can select. So 13C1 is 13 plus 4C1 is 4 minus 1 by 52C1 is 52. So here 13 plus 4 17 minus 1 16 by 52. If you cancel 4 by 13 should be the probability of selecting a diamond or king card. So in this way, whatever the question you are getting, you can find out the required answers based on the structure. So here you should understand the structure totally, what is the number of cards and what are the red cards, what are the diamonds or face cards. So face cards totally 4 types and each type is having 4. So 4 into 4 16. If as number cards totally, here it is 36 because in each type 9 there are 4 types. So 4 into 9 36. So in this way we can solve the questions which are related to here cards. Now let us take the next one related to balls. Suppose I am having a box. In this box I am having suppose 6 blue balls, suppose 7 green balls, and let us take 5 red balls. If I ask you to select a ball which is red color, I want the probability of selecting that. So here the question will be, what is the probability of selecting, two red balls from the box? First of all, here we should consider the number of favorable chances. So selecting 2 red balls, totally there are 5 red balls, so we are selecting 2 red balls, so the number of favorable chances is 5C2. So by what is the total number of chances? We are selecting from this box indicates you may get any 2 balls, so that here totally 6 plus 7 13 plus 5 18. Out of 18 you may get any 2 balls. So total number of chances are 18C2. So in this way the probability answer will become 5C2 by 18C2 to select 2 red balls. Suppose if I ask you to select 3 balls of same color. So here what I want is 3 balls of same color. When we are selecting 3 balls of same color, for that I want the probability. So the probability is equals to, selecting 3 balls is nothing but you may select blue or green or red, any 3 of same color I want. So it may be 6C3 or means plus here 7C3 or means okay plus next red, that is 5C3 by whether I select 3 red or 3 green or 3 blue, always I am selecting only 3. I cannot select all at the same time. I may select any one out of these 3. So here totally we are selecting only 3. That's why it is equals to 18C3. So this is the probability of selecting 3 balls of same color. So in this way you can expect anything. Actually we discuss the number of ways of selecting any type of balls in combinations, whether it is 3 balls of same color, 3 balls of different color, or 2 balls of same color, or a red ball or a red and green. So we have discussed all the things. Now whenever I ask you to calculate the probability, take those number of chances or number of ways in the numerator by the denominator is simply representing the total number of ways. how I am getting total number of ways? Total balls here 18, out of 18 if I am selecting 4, 18C4, so NCR, selecting R from N is NCR. So in this way you can understand the required answer. Suppose instead of one box, if my box, there are two boxes. Suppose this box is having 4 red, 5 green. There is another box which is having 6 red, 3 green. Now my question is, if I want to select one ball from any box, what is the probability of selecting a red ball? So I want the probability of selecting a red ball. I am not asking from a particular box. You can select from any box where I want a red ball. But if you select a red ball from first box, it is different from the probability of selecting red from the second. Here chances are different. Now let's see how I can find. So here I may select a red ball from the first or second box. For that, what we can do is, first of all we should decide the box from which we are selecting. So in order to select a ball, first we should decide the box which we are here considering to select a red ball. Now let's see, out of these two boxes, to select a box, there are two, so we are having the probability of selecting a box. For one box the chances are 1, total 2 chances, so 1 by 2. To select a chance, it is 1 by 2. So 1 by 2 into, for first box if I consider, so the number of chances to select first box is 1 by 2. Out of 2 boxes, 1, that is 1 by 2. And I want a red ball here, so I can select the red ball. What is the probability of selecting red ball here? 4 red balls are there. I want one red ball, so 4C1 by here total 9 balls. So total number of ways will become 9C1. So here it is the probability of getting a red ball from the first box, or I may get the red ball from the second box. If it is second box, the probability of selecting the second box is 1 by 2 into the probability of selecting the second box is 1 by 2, but what about the selecting the red ball probability? So probability of selecting red ball will become here 6C1 by total 9C1. So in this way here we can find the probability. So it is nothing but 1 by 2 into 4 by 9 plus R represents plus 1 by 2 into here 6 by 9. Suppose if you want to calculate, you can calculate here 1 by 2 into 4 by 9 is 4 by 18, or you can cancel here value, so that is 2 by 9 plus here you can cancel, so 2 3 times 3 times, so it is nothing but 1 by 3. So 2 by 9 plus 1 by 3, LCM is 9, so 2 plus 3 times, so 5 by 9. So the probability of selecting a red ball from these boxes will become 5 by 9. So in this way, whenever you are having two boxes, we can select here a red ball, if not a green ball, or two red balls. Not only for two boxes, suppose if I am having 3 boxes, now the probability of selecting each box will become 1 by 3, 1 by 3, 1 by 3 into the probability in these boxes will get you the answer here. So depends upon the number of boxes. Suppose if I am having 4 boxes, each box is having 1 by 4, 1 by 4, 1 by 4 here probability. So to select that box, we are having 1 by 4 probability. first we must select the box, and from that box we should consider here the required balls, whether it is a red or green. Now, if it is related to numbers, suppose let me consider one situation where there are 100 tickets. I am having 100 tickets which are numbered from 1 to 100. There are 100 tickets which are numbered from 1 to 100. Now, if I select 2 tickets, what is the probability of selecting 2 tickets with prime numbers? So we want to select here 2 tickets with prime numbers. Now we can select any 2 tickets, but those 2 tickets must be having prime number. Now let's see. We know that the probability is having exactly 2 values. One is numerator, other one is denominator. Now let us see the numerator. So here I want to select 2 tickets with the prime numbers. We know that there are 100 tickets which are numbered from 1 to 100. Already we discussed the number of prime numbers from 1 to 100 natural numbers. So in the first 100 natural numbers, the number of prime numbers is always 25. So whenever you are selecting 2 tickets which are having prime numbers, definitely you must select from these 25. You cannot select from any other. That's why selecting 2 out of 25 prime number tickets is 25C2 by, you know, the total number of ways. There are totally 100 numbers. So you can select any 2 100C2. So 25C2 by 100C2 is giving the probability of selecting 2 tickets with the prime numbers. Instead of asking selecting 2 tickets with prime numbers, suppose if I am selecting here a ticket, 1 ticket with suppose perfect square, a ticket which is having a perfect square. So out of 100 natural numbers, we are having 1, 4, 9, 16, 25, 36, here 49 and so on. You will be having exactly 10 perfect squares. So from these 10 only we must select one. That's why 10C1 by any 1 ticket you can select. So 10C1 by 100C1 or 1 by 10. Not only selecting a ticket with prime number or perfect square, it may be a multiple of 8. So out of 100, how many multiples of 8 are there? For that, simply no need to here calculate all the multiples. Simply what you can do is how many times, so 8 can divide here 100. So the maximum you can expect is here 2. If you take 12 times, it is beyond. Okay, so 12 times of 8 is exactly, we are getting as, so when you take 12 times of 8, 96. So from this we are getting the maximum number of chances are 12. So the number of multiples what we are having below 100 is 12. So from these 12 we need to select one. That's why 12C1 by 100C1. So whatever the multiple, suppose if I am asking a multiple of 6, there are 16 multiples. So 16C1 by 100C1. So in that way, whatever the value we want, we can select from the here available values. It is related to the numbers whenever we are having. Okay.